Try something for a second. Picture nothing. Not empty space, not a dark, silent void. Those are still something, space that exists, darkness that's there. Strip all of it away, no space, no time. No where, no when, no place for anything to happen, and no moment for it to happen in. You can't do it, your brain refuses. It keeps sneaking in a little bit of something, a black room, a quiet emptiness. Because a mind built inside a universe has no setting for true nothing. And yet, according to our best science, that impossible blank is exactly what came before the Big Bang. Out of that, somehow, came everything. Every star, every galaxy, every atom in your body. But here's the part that started to crack the whole story open. In the last 2 years, our most powerful telescopes have begun finding things at the edge of time that, by the rules of physics, simply should not be there. And those impossible objects are quietly forcing scientists toward a staggering idea that the Big Bang may not have been the beginning at all. Today, we're going to follow the evidence back to that wall and ask what was waiting on the other side. Let's start with the objects breaking the rules. The James Webb Space Telescope was built to catch the faint infrared glow of the very first galaxies. It's effectively a time machine pointed at the dawn of everything. And almost immediately, it started finding things it wasn't supposed to. In 2025, Webb confirmed a galaxy called MOMS 14, the most distant object humanity has ever seen. Its light left it just 280 million years after the Big Bang, when the universe was barely 2% of its current age. There shouldn't have been enough time to build something so developed. It should have been a faint smudge. Instead, it was bright, actively forming stars, with a chemical fingerprint resembling the ancient star clusters in our own Milky Way today. And it isn't a fluke. Webb keeps turning up far more big, bright, early galaxies than anyone predicted. The early universe was building massive structures far faster than our models say it could. Then there's the second anomaly, on a scale almost impossible to hold in your head. One bedrock assumption of cosmology is that, zoomed out far enough, the universe looks the same in every direction, with no single structure larger than about 1 billion light years. Then, in 2024, astronomer Alexia Lopez spotted something that shouldn't fit: a vast, nearly perfect loop of galaxies about 1.3 billion light-years across, now nicknamed the Big Ring. And it has a neighbor, an even larger structure called the Giant Arc, stretching some 3.3 billion light-years. For scale, the entire supercluster our galaxy belongs to is only about 500 million light-years wide. And closer analysis suggests the Big Ring may not even be a ring, but a vast corkscrew twisting through space. By the rules of our best theory, neither should exist. So we have two mysteries pulling the same direction: galaxies that grew up too fast, and structures that grew too large. Both whisper the same message: our story of how the universe began may be missing a chapter. To find it, we have to travel back to the oldest thing it's physically possible to see. When you look into deep space, you're looking backward through time. Look far enough, and you slam into a barrier you can't cross, a faint, uniform glow nearly 14 billion years old, beyond which no telescope will ever see. Here's what it is. Rewind to the first second after the Big Bang. The universe is a furnace, too hot for atoms to survive, and light is trapped, scattering off loose particles. For hundreds of thousands of years, the cosmos is an opaque fog. Then, roughly 380,000 years in, it cools just enough for the first stable atoms to form. The fog lifts all at once, and light races freely across space for the first time. That ancient light never stopped traveling, stretched by the expansion of space into a faint hum of microwave radiation from every direction. We call it the cosmic microwave background. The oldest thing anyone can ever observe, a photograph of the universe as a newborn. And it isn't blank. Across it are tiny variations, patches slightly hotter and cooler, the seeds of everything. Places that were a touch denser and pulled in more matter under gravity, growing into the galaxies we see today. In early 2025, the Atacama Cosmology Telescope released the sharpest version of that map yet. Detailed enough to capture not just where the early matter sat, but how it was moving. But the CMB is a hard ceiling. That glow is the wall. We can't see a single instant earlier, because before that point, the universe was opaque to light itself. To go further back, we have to turn to theory. For most of the last century, the standard answer to what came before was as tidy as it was disturbing. Nothing came before, because there was no before at all. Run the universe's expansion backward, and everything collapses toward a single point of infinite density. And there, the equations suggest time itself begins. Asking what came before is like asking what's north of the North Pole. There's simply no there. Clean, defensible, and deeply unsatisfying, it doesn't answer the question so much as declare it off limits. And it sits awkwardly beside everything we just saw. Which is why a growing number of physicists are taking a once unthinkable possibility seriously. What if the Big Bang wasn't the start of everything, but a doorway between one universe and the next? The first version comes from Nobel laureate Roger Penrose in a framework he calls conformal cyclic cosmology. In his picture, our Big Bang wasn't a creation from nothing, it was a transition. He imagines the far future of a universe like ours, expanded into near total emptiness, all its matter long since decayed. And he argues that this cold, empty state begins mathematically to resemble the blazing conditions of a new Big Bang. The end of one cosmos becomes the birth of the next. Penrose even claims to find faint circular patterns in the CMB. Echoes, he says, of a universe that existed before ours. The second idea is the Big Bounce. Several quantum gravity models suggest that instead of beginning at a singularity, our universe was born when a previous one collapsed inward and rebounded outward, like a ball hitting the floor and springing back up. No infinite point, no true nothingness, just a contraction that flips into expansion, with time running straight through the bounce. There genuinely was a before, the dying universe that became ours. The third idea, from physicist Richard Liu in 2025, may be the most radical. What if there was never a single Big Bang, but a whole series of them? Liu proposes the universe has been periodically fed by what he calls transient temporal singularities, abrupt, brief bursts of matter and energy that flash into existence everywhere at once, then vanish too quickly to catch. Each burst would do exactly what we currently credit to dark matter and dark energy. In his universe, the Big Bang was just the first flicker in a long chain of creation. Every one of these is still speculative. But notice what they share. Each one takes the beginning, that sealed and final wall, and turns it into a door. And here's what lifts this above pure philosophy. The universe recently handed us a real clue that some version of these ideas might be true. For decades, the simplest assumption about dark energy, the force driving the universe to expand faster and faster, was that it's a constant. If so, the universe accelerates forever, growing colder and emptier without end. But in 2025, the Dark Energy Spectroscopic Instrument, which has mapped millions of galaxies, delivered a result that rattled cosmologists. Dark energy may not be constant after all. Its strength appears to be slowly weakening over cosmic time. Think about what that means. If the force pushing everything apart is fading, then expansion won't necessarily continue forever. One distant day, it could slow, stop, and reverse, collapsing the cosmos inward toward a fiery endpoint, sometimes called the Big Crunch. And a crunch like that is precisely what the cyclic theories need, the collapse of one universe sparking the next. The very ending those theories require may already be faintly written into the data we're collecting right now. So, how did nothing exist before the Big Bang? The honest answer is that we still don't know. It remains one of the last true frontiers of science, where observation runs out, and only mathematics and imagination can press further. But think about how far the question has traveled. It started with that impossible blank you couldn't picture. Then it ran into galaxies that grew too fast, and structures too vast to explain. And the deeper we chase those mysteries, the more that glowing wall, the one we long treated as the absolute edge of reality, starts to look less like an ending, and more like a door we simply haven't learned how to open. If our universe really is just one link in an endless chain, bang after bang, cycle after cycle, world after world, then maybe, somewhere in that ancient light, or in the strange architecture of those impossible structures, there's a fingerprint waiting to be found. The faint signature of a universe that lived and died so that ours could begin. So which feels more believable to you? A universe that sprang from absolute nothing, or a cosmos that never truly had a beginning at all? Let me know down in the comments.